How will the space shuttle attach to the ISS?
Describe 2 ways that the International Space Station will stay in Earth's orbit.
Describe the function of the solar arrays, thermal radiators, robotic arm, and truss.
I'd like to welcome NASA Connect this morning to the Johnson Space Center here in Houston. My name is Connie Van Prae Kremens, and I work with the International Space Station program doing outreach and communications. What we're building in outer space is a world-class research facility. The United States NASA is the lead integrator of the program. ESA, the European Space Agency, the Russian Space Agency, the Japanese Space Agency, and the Canadian Space Agency all own the International Space Station, and as partners bring elements and people and training and research and all the facilities that we're building to our orbiting facility. In 1998, we began with a Russian-built, US paid-for module called Zarya. What it was is the initial power block and brains of the station. Soon after that, we launched Unity. That was a Boeing-built United States element. Unity is one of 3 connecting bridge modules that will be put on the International Space Station. After we put Unity up came the service module. That's an entirely Russian element. It's Russian-built and Russian-launched. And the service module actually took over much of the functions that we had of Zarya. And it also is the place where the astronauts live, work, and sleep.
How does the shuttle dock to the space station?
Well, that's what Unity provides. Unity has 6 docking ports. So the shuttle comes up and docks to a pressurized mating adapter, which is attached to the Unity bridge. And then through there, supplies can be moved into the space station.
So how will the station get power for the astronauts to use?
From the sun. What the International Space Station has is a series of giant solar arrays, photovoltaic solar arrays. We have 1 set of arrays up there right now. There'll be 4 in total that be aligned along the truss.
What exactly is a truss?
The truss is a backbone girder-like structure, and you'll see this long, almost like steel beam crate box, and that is literally what these solar arrays are going to be attached to. It's what modules are hung from, and the astronauts will be walking along it. Also walking and riding along it will be the Canadian robotic arm system for the International Space Station. Attached to the arm is what we call a special dexterous manipulator system, or a very smart hand that can go along and pick up different parts, modules, and move it around.
Okay, so I know that the solar arrays are on the truss, but what are the other, panel things?
Van, you're probably talking about the thermal radiators. That's the heat rejection system. Much like an air conditioning system would function in your home, the job of these radiators is to collect the buildup of heat and power generated internally and use it to move that heat outside the space station and dump it into space so that we can maintain comfortable levels of working for the astronauts and for the systems.
Now, I know the ISS is in a state of free fall, Connie, but how does it stay up in orbit?
Well, initially, we have attitude control thrusters that will continue to operate throughout the life of the station. These are the little jets that use fuel to keep our attitude.
What do you mean by attitude control?
Well, Jennifer, the space station has to maintain a certain position as it's being constructed. We want to get the maximum exposure to the sun for the arrays, so the attitude control is what keeps this position of the station.
So how do you know the pieces are going to fit together when you get them in space?
Well, this is part of the miracle challenge that confronts the International Space Station program, because these major elements have to fit together with hairline tolerance the first time when they're attached in Earth orbit. All the flight elements are literally put in line on their way to get integrated into the shuttle. What we can't do physically, we're doing through software. In fact, controlling the International Space Station is going to take more than 2 million lines of computer code. And we're learning valuable things through that testing. We're fixing problems before they ever become a problem on orbit.
Thank you so much, Connie.